Good day, dear students. We are now looking into topic 1, numerical solution. This is topic 1 of semester 2. We have two subtopics in topic 1, which are numerical solutions of equation and Newton-Raphson method. The first, we focus on numerical solutions of equation. Let's look at what is our learning outcome. At the end of the lesson, all of you must be able to locate approximately a root of an equation by means of graphical consideration, graphical consideration or searching of a sign change. So we have two methods to approximate a root. Okay, first we must understand we are not finding the root, we are just approximating root in this chapter. Okay, so this is approximation of a root. And there are two methods. One is graphical, second is searching for a sign change. Okay, now let's look at the given notes here. So some of the non-linear equation. So be very careful. They are talking about non-linear equations have no roots. Okay, yeah, some equation does not have any root or difficult to solve the equations to find the roots. For example, x minus exponent x equals to 2. Let's say we are asked to find a root for x minus exponent x equals to 2. So you need to understand when they say finding the root, you need to understand that they are actually asking you to find the x-intercept. So when we are talking about roots, we are talking about x-intercept. So when does x-intercept occurs? Y is 0. So in this example, x minus exponent x minus 2 equals to 0. So finding the value of x at the end, solving for x will give us the root. Now it's not that easy to find the value of x for equations such as x minus exponent x or equations as ln x plus 4 equals to x squared. It's quite difficult to find the roots even by using calculator. So in these cases, numerical methods, which is chapter 1, numerical methods can help to find the approximate roots, not the exact roots, but the approximate root for the equation. Okay, so to solve fx equals to 0, so first must understand why we are solving fx equals to 0. It's because we are finding the roots. The first approximation of the root can be obtained by, as I told you earlier, two methods, change of sign and graphical method. Okay, first we focus on change of sign. If fx is a continuous function on the interval ab, then fa greater than 0 and fb less than 0. Okay, what is the meaning of fa? Substituting the value of a in the interval into the function and also substituting the value of b and making sure that there is a change of sign. Doesn't matter, you can have fa greater than 0, fb less than 0 or fa less than 0, fb greater than 0. Therefore, fx as a root in between x equals to a and b. So this is a method where we call change of sign. Now let's look at example 1. Okay, so we are going to use change of sign to show that the equation x cubed plus x minus 3 equals to 0 has a root lying in the interval 1, 2. Okay, now okay, first of all, we are going to write down what is fx. Okay, so fx is x cubed plus x minus 3, and we would like to show that there is a root lying in between 1 and 2. So what is the meaning of there is a root lying in between 1 and 2? If you can see that this is a cubic function. So basic shape of a cubic function is something like this. The meaning of there is a root lying in between 1 and 2 is there is a x-intercept in between the value of 1 and 2. So this is the root. The x-intercept is the root. Now how to show by using change of sign? So since the given interval is 1 until 2, we are going to substitute f1 into the given equation. 1 cube plus 1 minus 3 will give us negative 1. So need to state whether it is less than 0 or greater than 0. Next, we are going to try with f2. 2 cube plus 2 minus 3. So we will be getting 7, which is greater than 0. So note that we have a change of sign. One is less than 0, one is greater than 0. So we are going to write a conclusion here. Since f1 and f2 have, you can use the word different sign, or you can also use the word opposite signs. Okay, since f1 and f2 have opposite sign, therefore, okay, so what did the question ask us? The question asks us to show that the equation has a root. Okay, therefore the equation x cubed plus x minus 3 equals to 0 has a root lying in the interval. So the given interval is 1, 2. Now this is the method change of sign. Okay, so when there is a change of sign, then there is a root. So I hope you can understand the method of change of sign to approximate a root. We have not approximated the root. We just show that there is a root. Now, if you look at the second part here, example 1b, hence determine an approximation. This is where we are going to determine an approximation for the root. Since the root is in between 1 and 2, so to answer the B, okay, so the approximation root, yeah, the approximation root, you can write any value in between 1 and 2. So usually the approximation root will be in between the interval 1 and 2. So we can usually we take the mid value of 1 and 2, which is 1.5. So the approximation root is 1.5, and usually the first approximation we note it as x naught. So x naught is 1.5. So that's the answer for example 1. Now let's look at example 2. So in example 2, we are already focusing on graphical method. Yeah. So on a single diagram, sketch the graph y equals to exponent x and y equals to negative 2x plus 2. So we are going to sketch two graphs on a single diagram. Hence, find the interval a until b where a and b are consecutive positive integers in which the point of intersection lies. So you need to find the interval where the point of intersection lies, then determine the approximation value of x naught. Okay, so first we answer the sketching graph. Okay, first we sketch the graph of exponent x and negative 2x plus 2. Okay, so now this is the graph of exponent x, okay, where it intersects at 1 and approaches 0. Now this is the graph of y equals to exponent x. Next, we are going to sketch the graph of y equals to negative 2x plus 2. So note that the x and y intersect. So when x is 0, y is 2, and when y is 0, x is 1. Yeah. So we got the intersection at 2 and 1, and this is a straight line with a negative gradient. Okay. Is to label your y and x axis, label your straight line y equals to negative 2x plus 2. Okay, so now this is to answer the first part of the question. Okay, now let's look at the first part of the question. First part of the question, on a single diagram, sketch the graph of exponent and the straight line. So we have answered the first part, which is sketching the graph of a straight line and the exponential function. Now on the second, this is intersection at 1. Huh? Okay, intersection at 1. Okay, now let's look at the second part. The second part, find the interval a less than x less than b. Find the interval a until b, where a and b are consecutive positive integers in which the point of intersection lies. Okay, so the point of intersection of these two graphs is here, somewhere here. Okay, somewhere here. Okay, so it lies in between 0 and 1. Okay, so the interval, they are asking us for the interval. Find the interval. So your answer must be in interval form. So the intersection point lies in between 0 until 1. So the interval, the interval where the intersection point lies. The interval is 0 until 1. Okay, so we need to write it in interval form. Okay, next. Then determine the approximation value of the x naught. So approximation of value of x naught, this is where x naught is. So we can give any value in between 0 and 1, but it looks like it's exactly in the middle. So preferably we would like to write x naught is 0.1 as the first approximation. So this is the first approximation. Okay, I hope you can follow this. Okay, now let's look at example 3. Given x exponent x equals to 1, use graph to find an approximation for the root of the equation. Okay, now it's going to be quite difficult to sketch the graph of exponent x equals to 1. Okay, so preferably we will write to change this. Okay, preferably we will prefer to write this as maybe x exponent x is 1. Maybe we can write this as exponent x is 1 over exponent x. So we won't be finding the root at x-intercept. We will be finding the root at intersection of the two functions. So we separate this into two functions. We can draw the graph of y equals to x and also another function, function 1 and function 2. So the second function will be y equals to exponent negative x. So we draw this separately. We don't draw as one function because we really don't know how to draw the graph x exponent x equals to 1. So we make it into two functions that we know how to sketch. So first we sketch the straight line y equals to x. Okay, now this is the straight line. Sorry. Okay, let's try again. Okay, now this is the straight line y equals to x where it passes through 0, 0. And we need to sketch the graph of y equals to exponent negative x. Please note that there is a negative in front of x. So our function y equals to exponent x is the basic shape of y equals to exponent x. Negative in front of x we will reflect at y. So this will be the shape of y equals to exponent negative x. Okay, something like this. Y equals to exponent negative x passing intersect at 1. So this is y equals to exponent negative x. Okay, so they ask us to use the graph to find an approximation for the root of the equation. So when we draw two separate graphs, okay, the root will be, approximation of the root will be the intersection point of the two function. So where does they intersect? The two graph intersects in between 0, we can say 0 to 1. Yeah. So use the graph to find the approximation of the root. So the approximation of the root will be 0.5. First approximation. Huh? So that's how we use graphical method to find the approximation root of a given function. Okay, next we are going to enter the second subtopic, which is Newton-Raphson method. Okay, in Newton-Raphson method, we are not approximating the root. We are already finding the root for the nonlinear equation. So what is Newton-Raphson method? Okay, we have a formula for Newton-Raphsons. So what is the Newton-Raphson formula? Xn plus 1 equals to xn minus fxn divided by f prime xn, where x starts at 1, 2, and so on. So what are the steps in Newton-Raphson? First, we need to identify the first approximation. So we have two methods to identify the first approximation. One is graphical consideration, another one is change of sign, which we have done before. And then we need to differentiate fx because the formula has f prime x. Calculate using the Newton-Raphson method formula repeatedly until the answer was satisfied. Okay, now this is the steps where we will be using calculator to uh, find our root. So please take note of these steps. Okay, make sure you clear the memory of your calculator, and then insert your expression and follow the instruction by pressing calculate and insert the first value, and then by finding the approximation for the next value and so on. Okay, now let's see how to find root by using Newton-Raphson. Okay, example 4. Use Newton-Raphson method to find the real root, not approximate root, to find the real root of the equation 2x cubed minus 5x minus 1 equals to 0. Correct to 4 decimal places. Start with the initial value x naught equals to negative 0.5. Now, please bear in your mind for this chapter, when we are given 4 decimal places, calculation should be more than 4 decimal places. Final answer will be 4 decimal places. Okay, yeah? So this is for your final answer. So make sure your calculation is for greater than 4 decimal places. Okay, now let's look at the steps suggested in our lecture notes. So the first step is to identify the first approximation. For some question, the first approximation are given. For example 4 here, they have given us the first approximation. Start with the initial value x naught equals to negative 0.5. So that is our step 1. Step 1 is to identify the first approximation. X naught is negative 0.5. Now step 2, suggestion from the lecture note is to differentiate fx. Okay, that will be step 2. Differentiate fx. So what is fx? Fx is 2x cubed minus 5x minus 1. So what is f prime x? Differentiate fx. F prime x is 6x minus 5. Okay. So step 3 is to calculate by using Newton-Raphson repeatedly until the answer is satisfied. So step 3, we have to use Newton-Raphson. Therefore, you need to know the formula of Newton-Raphson. Xn plus 1 equals to Xn minus Fxn divided by F prime Xn. So in our case, fx and f prime is as how written. Now how to find xn plus 1? So what is xn? Xn is x naught, which is 0.5. So what is xn plus 1? It will be x1. So what is xn plus 1? X1 is x naught minus fx naught. Fx is 2x cubed minus 5x minus 1. Okay, fx naught divide by f prime x naught, which is 6x naught minus 5. Okay, so that's how your formula will be. Now let's see how to find x1. We are supposed to substitute x naught, which is 0.5 minus 2 times 0.5 cube minus 5 times 0.5 minus 1 divided by 6 times 0.5 minus 5. Okay, so you can manually press your calculator or you can follow the given steps here. Okay, so we have steps to key in the whole function into the calculator to find the iteration value. Now let's see, when you calculate this either by calculating manually, pressing your calculator, or by inserting the formula as the steps given. So you will be getting x1 as negative 0.14286. Notice that I am using 5 decimal places because the question asks for 4 decimal. Calculation should be more than 4 decimal places. Okay, now what is x2? Okay, next we are going to continue with the iteration. So that's what suggested in the lecture notes. Okay, calculate using the Newton-Raphson formula repeatedly. So you have to repeat this until the answer is satisfied. So you have to repeat for x2. So what is x2? Negative 0.14286. Now we are going to substitute x with the value from the previous, which is negative 0.14286 minus with 2 multiply negative 0.14286. From 0.1, the root has shifted to negative 0.14286 minus 5 times negative 0.14286 minus 1 divide by 6 times negative 0.14286 minus 5. So if you calculate this, you will be getting negative 0.20263. So notice that I still use 5 decimal places, and let's look at the difference between the value of x naught, x1 and x2. So earlier x naught is 0.5, x1 is negative 0.1286, x2 is negative 0.20263. So we are going to continue this until we get the correct root. So what is the correct root? When we get the same value. Okay, so we are going to continue this for x3. So for x3, we will be using the value of x2, negative 0.20286. 20263 minus with 2 times negative 0.20263 minus 5 and substitute negative 0.206 20263 minus 1 divide by 6 times negative 20263 minus 5. Okay. I think I differentiate here should be 6x square. So this is square, sorry. But the way the answers are correct, because I've done this earlier. So there's a square here. Okay, now let's look at the answer here. So this answer will be negative for x3. Yeah? X3 here, we are getting negative 0.20336. Okay, so note that x2 and x3, we are still not getting the same value. So we have to continue with the iteration to x4. So for x4, we are going to use x3, negative 0.20336 minus 2 times negative 0.20336 minus 5 multiply negative 0.20336 divide by 6 times negative 0.20336 square minus 5. Okay, and for x4, you will be getting negative 0.20336. Okay, finally, we are getting the same value, which means this is already the root, the very nearing to the exact value. Yeah, so before this, the difference is very large, so it is still not the exact value. Once you can get the difference is very small, for example, x3 and x4, okay, it's the same value, that means there is no difference. Therefore, we can say root, the root is negative 0.203. Okay, I'm not going to write the answer to for 5 decimal places. I'm going to write the answer to 4 decimal places because that's what the question asks. But the calculation should be 5 decimal places. Okay, let's look back at Newton-Raphson method. So what is Newton-Raphson method? First, we need to identify the initial value. Second, we need to differentiate the given function. Third, we need to substitute the initial value into the Newton-Raphson formula to get the next value that is nearing to our root. And we will continue the iteration until the values are same. So once the value is same, we can say that this is the root for the given function. Yeah. So we have answered example 4 using Newton-Raphson method to find the real root of the equation 2x cubed minus 5x minus 1 equals to 0. Okay, I hope you can follow this. Now let's look at example 5. In example 5, show that the equation 2 sine x minus x equals to 0 has a root in between x equals to 1 and x equals to 2. Hence, by using Newton-Raphson method, find an approximate root of the equation correct to 3 significant figure. So now look at the remark here. This is very important. Be cautious that x is measured in radian. So why x is measured in radian? One, the given function is a trigonometry function. Okay, when we are given a trigonometry function, we have to be very careful of the whether we are using radian or degree. Next, if you look at the root given at the value of x, if you look at the value of x, 1 and 2 is not in degree. Okay, it's not in degree. It doesn't have a degree symbol. That means this is radian. Okay, so we don't write 1 radian and 2 radian, but as long as we do not have the symbol degree, that means this is definitely in radian. So you have, when you want to use your calculator to find the root, when you want to use the iteration and all that, please make sure that you change the mode to radian. Okay, now we want to answer the first part of the question, which is show that the equation has a root. I hope you can still remember how to show that there is a root. Now first, copy what is fx. So fx is 2 sine x minus x, and we want to show that there is a root in between x equals to 1 and 2. To show that there is a root in between x equals to 1 and 2, we will substitute f1, which is 2 sine 1 minus 1. Please make sure your calculator is in radian. So if you press this, you will be getting 0.6829, and the conclusion for this is greater than 0. Next, we are going to substitute f2, 2 sine 2 minus 2, which will give us negative 0.1814, and the conclusion for this is less than 0. So how are you going to show that there is a root? We are going to write the conclusion since f1 and f2 have opposite sign. Okay, they have opposite sign. Therefore, the equation 2 sine x minus x has a root between x equals to 1 and x equals to 2. So I hope you can still remember on the method change of sign. Okay, next, they very clearly told us to use Newton-Raphson to approximate the root. So to use Newton-Raphson, we need initial value. So let's check if any initial value given in the question. So when we read the question, there is no initial value. But we know how to find initial value. We know definitely the root is in between f1 and f2. So the initial value will be in between f1 and f2. So we can take initial value as 1.5. That is the step 1 for Newton-Raphson. Step 2, you need to differentiate your fx. Okay, 2 sine x minus x, you need to find f prime x. So f prime x will be 2 cos x minus 1. Yeah, make sure you find the correct f prime. Next, we are going to use Newton-Raphson. So make sure you know the formula of Newton-Raphson. Xn plus 1 equals to Xn minus Fxn divided by F prime Xn. Okay, so in this case, X1, okay, X1 equals to x0, which is 1.5 minus fx 2 sine 1.5 minus 1.5 divided by f prime 2 cos 1.5 minus 1. Okay, so you can either key in into the calculator, or you can use the formula to find the iteration. Okay, now once using the calculator, make sure the calculation is more than 3 significant figures. Make sure it's more than 3 significant figures. So the answer here is 2.077. So this is 4 significant figure. Okay. Okay, next we are going to find x2. Okay. So there is a big difference between 1.5 and 2.077. So we need to continue the iteration with x2 equals to 2.077 minus 2 sine 2.077 minus 2.077 divided by 2 cos 2.077 minus 1. Okay, so using the calculator, we will be getting 1.911. So note that there is a big difference between x1 and x2. So we need to continue this to x3. So what is x3? 1.911 minus 2 sine 1.911 minus 1.911 divided by 2 cos 1.911 minus 1. Okay, so when we use 1.911, we will be getting 1.896. There's still a big difference between 1.911, so we are still quite far from our root. So we need to continue to x4. 1.896 minus 2 sine 1.896 minus 1.896 divided by 2 cos 1.896 minus 1. So we will be getting 1.895. So this is almost similar, but still it's not the same. So we will continue until we get the same value. So the next iteration will be 1.895 minus 2 sine 1.895 minus 1.895 divided by 2 cos 1.895 minus 1. So when you're using the calculator, we will be getting 1.895. Note that the two values are the same. That's when we decide to stop the iteration. We cannot continue. So what is the solution for this? To three significant figure, no more four significant figure. Three significant figure will be 1.90. So this is how you write for three significant figure. Be very careful. If you write 1.9, you will not get marks because this is not three significant figure. This is two significant figure. Make sure to write 1.90. Okay, now, so there's one more example for us to have a better understanding. So let's look at example 6. So example 6 show that the equation 2x equals to 3 ln x plus 1 has a root in the interval 1 until 2. Use Newton-Raphson method with an appropriate first approximation to find the root of the equation correct to 4 decimal places. Okay, first of all, we need to find out what is fx. So given equation 2x is 3 ln x plus 1. So how to find fx? You need to transfer your 3 ln x plus 1 to your left hand side and equate to 0. That's when we will be getting our fx, which is 2x minus 3 ln x plus 1. Now this is our fx. Okay, so we need to show that there is a root in the interval 1 until 2. Let's start with f1. Okay, so what is f1? 2 times 1 minus 3 ln 1 plus 1. So by using calculator, we will be getting negative 0.0794, which is less than 0. Next, we are going to find f2. 2 times 2 minus 3 ln 2 plus 1. Okay, so you will be getting 0.7042, which is greater than 0. So to show that there is a root, okay, you have to show that there is a change of sign in between the two values. So you need to write your conclusion. Since f1 and f2 have opposite sign, okay, since they have opposite sign, therefore, okay, therefore the equation, so what is the given equation? 2x equals to 3 ln x plus 1, okay, sorry, 3 ln x plus 1 has a root between x equals to, not x equals to 1, sorry, have a root in the interval, right? Yes, have a root in the interval, interval 1 until 2. So that's how you show that there is a root. Okay, next we need to find by using Newton-Raphson. Okay, so for Newton-Raphson, we need a initial value. So initial value is not given in the question. They ask us to find using a appropriate first approximation. So appropriate first approximation will be in the interval 1 until 2. So usually the first approximation is the mid value. So the mid value for this will be, hold on, okay, wait, 1 until 2. Okay. So the mid value between 1 and 2 will be 1.5. Okay. Next, for Newton-Raphson, we need to find f prime. So we write down fx first. 2x minus 3 ln x plus 1. Next, f prime. 2 minus 3 over x plus 1. Okay, so what is Newton-Raphson? Xn plus 1 is xn minus fxn divided by f prime xn. So in our case, x1 equals to 1.5 minus 2 times 1.5 minus 3 ln 1.5 plus 1 divided by 2 minus 3 over 1.5 plus 1. Okay. So you should be able to get the first first value for x1. Um, Let me, very sorry, I would like to change the first approximation to 1.3. Okay. So I've used 1.3 for my first approximation. You can use 1.5, doesn't matter. But I would like to use 1.3 as long as the value is in between 1 and 2. So if we are using 1.3, the first value here will be 1.15442. Okay, now for x2, you need to do the whole iteration again for using the value of 1.15442. Okay. Okay, give me a few minutes, yeah. So make sure your calculation, make sure greater than 4 decimal places. Yeah. So if you notice that this is 5 decimal places. Okay. 3 log 1.15442. Okay. So here we will be getting 1.14409. Okay, since these two values are still not the same, we have to continue the iteration with x3. So when you continue the iteration with x3 by substituting the value of 1.14409, by using 1.14409 into the given equation, you will be getting 1.4403. Okay, so we still have to continue since x2 and x3 are not the same value. We have to continue with x4 by using 1.4403 into the given iteration, and we will be getting 1.4403 for the x4. So finally, we are getting the same value. So we can conclude that the solution is 1.440. Please take note, the final answer is for 4 decimal places. So that's how we find root by using interruption. So we have to do the iteration until we get the desired value. Okay, thank you, student. So we have finished neutral absent. So by when we have finished neutral absent, we have also finished chapter 1. So I hope all of you are able to find root by the neutral absent method, and also are able to uh, the first learning outcome, locate approximately a root of an equation by means of graphical consideration or searching for a sign change. So I hope you are able to uh, answer both the learning outcomes. So that's all for lesson 1. Thank you, students.